Alright, we got the Sunday night homework blitz. We're starting off with number 79. We're given our time for trip A. We're given our velocity for trip A. We are given our time for trip B. We're given our velocity for trip B. The question is, what is the car's average velocity? Well, the equation for average velocity is the displacement over the time. We don't have the displacement. We got to figure that out. So for each segment, you can just multiply the time times the velocity. You will see that the units cancel out to give you kilometers, which is displacement. Same thing for trip B. Multiply the time times the velocity. The hours cancel out. You're left with kilometers, which is displacement. Put your kilometers over your time, which is 4 hours, and you'll get your answer. Next part. Again, equation for average velocity, displacement divided by time. In this case, you're given the displacement because it's 2 trips of 100 kilometers each, so that's a total of 200 kilometers. But the time you got to find out. The way to derive the time is you can take your displacement divided by your velocity, do that for A, do the same thing for B, and that will give you your time. Make sure you add them together and put that total time on the bottom, solve for average velocity. Number 81, we are given a velocity initial. We are given an acceleration. We are given a time. The question is, what is the final velocity? We can use our VF equals VI plus AT equation to solve for that final velocity. I'll show you exactly what the math would be here, just so it's crystal clear. Number 85. I'm gonna skip 83 because it's just graphing. 85. We're given. It's asking you to find the accelerations. Recall that the equation for acceleration is change in velocity over change in time. Do that for each car, and then rank them. 87. Let me see. We're given a graph. I want to remind you that in order to find the displacement from a VT graph, you simply find the area under the curve. That will be your displacement. Do that for each of the time periods, and there you go. All right. Number 89. Number 89. We are given a velocity. We are given an acceleration. And we are given 2 different times for part A and part B, and you're asked to find the displacement. You can use the d equals di plus vt plus 1/2 at squared formula for this one. There is not going to be a di, and but there is a vt. So here we go. Here's the math for you for trip A. Plug it in, do the same thing for B. Number 91, we got a car traveling at an initial velocity. You see a kid in the road, you should never stand in the road, it's dangerous. We have a reaction time, 0.8 seconds. We're given the acceleration. The question is to find the displacement. First, we're going to find the displacement just for the reaction time. During that reaction time, you can take the velocity times the time, just that reaction time, to find that displacement. Now we need to find the displacement after we've applied the brakes. You can use that equation there. I rearranged it for D. And recall that your velocity final is 0 because you're coming to a stop. So you got to find those 2 D's. Just the displacement that you traveled during the reaction time, just the velocity times time, and then the second distance, the second displacement that you found after you already started applying the brakes. Add those 2 together and you get your total displacement. Number 93. We're given a time, we're given a velocity initial, we're given a velocity final, and the question is, how far? Well, you can find your acceleration by doing the change in velocity over change in time. Once you have your acceleration, you can plug it into the equation Vf squared equals Vi squared plus 2AD, and you're solving for D here, so I'll rearrange it for you. And you're on your way. Number 95. We're given a velocity initial, velocity final 0 because we're going to slow down. We're coming to a stop. The distance is 40 meters. Watch out for units. We got kilometers and meters here in the same problem. We're given a reaction time, 0.75 seconds. We're given an acceleration. So let's find the displacement during the reaction time. You can take the velocity times time. Let's find the distance after you've started applying the brakes, and we can rearrange for D here just as I did a minute ago. Add those 2 displacements together. The question is it more or less than 40 meters? Are you going to hit the barrier or not? Next part, we're trying to find the maximum speed you could go without hitting the barrier. So here we're solving for the velocity initial. Velocity final is going to be 0 because you're coming for a stop. The acceleration is the same, and the displacement is 40 meters. Okay, we got 97. We're in free fall mode now, talking about gravity. We're given a displacement, we're given velocity initial because you're dropping it is 0. We're given the acceleration on the moon. The question is to solve for time. We can use this equation here, d equals di plus vt plus 1/2 at squared. We don't have a distance initial. There's no velocity initial because we're dropping it, so it's quite simple here. It's just, I'm rearranging it here and solve for time. Number 99. We're dropping a bag from a helicopter. So our velocity initial is 0. We're given the time, we're given the acceleration because it's on Earth, so it's negative 9.8. Asking to find for velocity final, you can use this equation here. Velocity final equals velocity initial plus at. Once you get that, you can solve for your distance here. 1/2 at squared. I've left out the earlier parts of that equation because, as before, there is no initial distance and there is no initial velocity. So it's just simply displacement equals 1/2 at squared. All right. Hope you had a great weekend.